Hello, my dear friends. I'm Professor Vyam Khan, and this is the part 3 of unit number 3 Control Action, Controllers, and Electrical System of subject Automatic Control System. In previous video, we have studied the types of controllers. In these types of controller, we have studied the proportional type of controller as well as integral type of controller. We have seen their block diagrams, we have seen their transfer functions. So in today's video we are going to continue with the controllers, the types of controllers, and today we will be studying the derivative type of controller and the combination of proportional integral controller. Okay, so without wasting so much time, I'll begin with the uh, lecture. Now, derivative controllers, the name itself suggests a derivative. We have seen proportional type of controller, we have seen integral type of controller. In proportional type of controller, the output is in proportion with respect to the input, and in integral type of controller, the output is in proportion with the is in proportion of integral of the input. So your output is dependent on the input in terms of its integration. In the derivative type of controller, the output is in a proportion with the derivative of the input. Okay, but we never use derivative controllers alone. We do not use them uh, alone. We use them always in combination with the other controllers like proportional controllers, as well as we combine them with proportional and integral controller. So derivative controller alone is not used because of some of the disadvantages, like it never improves the steady state error. It is not possible for derivative controller to improve the steady state error. Again, it produces saturation effects, and it also amplifies the noise signals produced in the system. Since it is a derivative type, it also increases the noise signals produced in the system. So therefore we never use derivative controllers alone. Okay, let us discuss this derivative controller now. As the name suggests, the derivative controller, its output, also called as actuating signal, is directly proportional to the derivative of the error signal. Now error signal is nothing but the input signal for the controller. Error signal is generated from the error detector by you can say by comparing the reference signal with the feedback signal, and error signal is generated, and that error signal is given to the derivative controller as an input. Okay, now let us analyze the derivative controller mathematically. You can see that here in equation u of t, that is your output, is directly proportional to the derivative of the error signal, that is your input. So det by dt is nothing but derivative of your error signal, which is directly proportional to the input, sorry, to the output signal. If you take a constant here, that is kd, then you can remove this proportionality sign and you can replace it by equality sign. So your equation will become u of t is equals to kd into det by dt, where this det by dt is nothing but derivative of your error signal. U of t is nothing but the output signal, and kd is nothing but your proportional constant, also known as controller gain. It is also known as controller gain. Okay, now the derivative controller is also called as the rate controller. Okay, it is also called as the rate controller. So remember that thing, it is also called as a rate controller. Now let us go ahead, let us apply Laplace transform on the both sides. So u of t will get replaced by u of s, kd will remain as it is, det by dt will get replaced by s into e of s. Okay, so if you take this e of s on the left hand side and put it in the denominator. So u of s divided by e of s will be equal to kd into s. Now this u of s into e of s is nothing but transfer function. It is nothing but transfer function. So a transfer function for the derivative type of controller is equals to kds. It is equal to kds. Okay, now kd, where kd is nothing but your derivative constant, also known as proportional constant, proportionality constant. U of s is nothing but Laplace transform of actuating signal u of t. E of s is nothing but the Laplace transform of the error signal e of t. Okay, remember that kds is the transfer function of a derivative controller. Okay, now let us go ahead. Let us see the diagram, block diagram of this derivative controller. It is given here. The block diagram is similar to the previous one, where this r of s is compared with this feedback signal. Okay, this is a negative type of feedback signal. Because of the comparison of this rs and feedback signal, an error signal is generated, which is given to this derivative type of controller. Its transfer function is kds, which is directly given here. Okay, this produces an output signal u of s, which is given to plant, which is having a transfer function gs, and that produces an output signal from that plant. Okay, so this is a block diagram of your derivative controller with a negative feedback closed loop control system. Okay, now remember that the derivative controller is used to make unstable control system into a stable one. Okay, remember, always remember that it stabilizes the system. Okay, therefore derivative controller can be used to stabilize the system, but remember, it is not used alone. Okay, it is always used in combination because it is having some certain disadvantages. Okay, so this was about the derivative controller. Let us go ahead. Let us see what is the advantage of derivative controller. The major advantage of derivative controller is that it improves transient response of the system. It really improves the transient response of the system, as well as it stabilizes the system. Okay, it also stabilizes the system. Okay, so these two are the advantages of your derivative type of controller. Now let us go ahead and see the combination type of controllers, in which first combination that we are going to study is proportional and integral type of controller. Now, as the name suggests, you can guess, or you can uh, see what is going to happen with this proportional and integral controller. In proportional and integral controller, the output, which is also called as actuating signal, is equal to the summation of proportional and integral of error signal. So your output signal is now dependent on the summation of proportional and integral of the error signal. Okay, if you want to write it like like with usual uh, proportionality sign, so u of t, sorry, so your u of t will be in proportion to the error signal. Okay, to the error signal t plus integral of e t dt. Okay, now if you want to replace this integral sign, you need to add two proportionality constants. So first one will be kp for this proportionality et, and second one will be ki for this second uh, integral. Okay, So you get the proportional integer controller in terms of mathematical form. It is given as u of t is equals to kp into e of t, where e of t is nothing but your error signal, u of t is output, and kp is your proportionality constant, and plus ki integral or integration of e of t dt. Okay, where ki is nothing but your integral proportionality constant. Okay, now let us apply Laplace to this equation. Let us now apply Laplace to this equation. Okay, so by applying Laplace on both of the side, u of t gets converted into u of s. Okay, kp et gets converted into kp into e of s. Ki integral of e of t dt gets converted to ki. Ki remains constant, and your e of t gets converted to e of s, and your uh, dt gets converted to 1 by s. Okay, so you get an equation which is equals to u of s is equals to kp plus ki by s, where e of s is taken common. Okay, kp plus ki by s into e of s, and if you take this e of s on left hand side, it will be going into denominator, and you will get u of s divided by e of s, which is equals to kp plus ki by s. Now this is nothing but the transfer function of pi controller. Okay, it is nothing but the transfer function of proportional integral controller, which is equals to kp by ki of s, which is equals to kp by ki of s. Okay, so please correct this. So the transfer function of your uh, proportional integral is equals to kp plus ki by s. Okay, where ki and kp are nothing but proportional constant and integral constants. Okay, now let us see the block diagram of this pi type of controller. It is given here. It is similar to the regular one, where r of s is nothing but your input signal. This is feedback signal, which is compared together and it generates error signal. This error signal is given to the pi type of controller. Its transfer function is kp plus ki by s. It then generates output signal u of s, which is given to the plant as an input, because it is also called as actuating signal. Then plant, which is having transfer function g of s, generates another output, that is the cs. So we take again feedback from this generated output and we give it to the error detector, where the process continues. Now remember that the proportional integral controller is used to decrease the steady state error. It is used to decrease the steady state error without affecting the stability of the control system. So it does not affect the stability of the control system. Remember that thing. Okay, so most of the time this PI type of controller or the combination of proportional and integral controller is used in your industry, and it is used because of this reason, specific reason. It decreases the steady state error without affecting the stability of the control system. Okay, now there are some advantages and disadvantages of this proportional and integral controller, which are like PI controller may reduce the stability, it may reduce the stability, but its main advantage is that it reduces steady state error very drastically. Due to this only reason, it is one of the most widely used controller in industry. So this was all about proportional integral type of controller and derivative type of controller. In next video, we'll continue with this types of controller. We'll study what is the PD type of controller, that is proportional derivative controller, how its combination is going to work, and what are the equations, mathematical equations related to them, as well as we are going to study the combination of three PID controller, that is proportional, integral, and derivative controller. What happens when these three are combined together, and what are the various advantages of these remaining two types of controllers. Till then, please stay safe, stay at home, and keep learning. Thank you.